Okay, we're continuing with the Econometrics final review. For question 3, we have the following regression where the dependent variable is the natural log of GDP for Starbucks country, and the two independent variables are the natural log of labor and the natural log of capital. And we can see here that the number of observations is equal to 31. So it's asking you what the coefficient on x1 means. So that's the coefficient on the natural log of labor. And so that means as labor goes up by 100%, predicted GDP for Starbucks country goes up by 30%, holding capital constant. And so for the next coefficient, on the natural log of capital, we can tell that as capital goes up by 100%, predicted GDP for Starbucks country goes up by 15%, holding labor constant. Okay, so what does the r squared mean here? The value of r squared of 0.82 means that 82% of the variation in the dependent variable, which is the natural log of GDP for Starbucks country, can be explained by the variation in the independent variables. All right, suppose we want to test the hypothesis that the natural log of labor has an effect on the natural log of GDP. What are the correct hypotheses? So the null hypothesis would simply be that, so we're testing this, so it's that beta 1 is equal to 0, and the alternative hypothesis is that beta 1 is not equal to 0. And so this is clearly because we're looking at a not equal to, and we're not necessarily looking at whether it's positive or negative. It's clearly a two-tailed test. Okay, now we have to look up the absolute value of the critical t-value for an alpha of 10%. And so we're looking at a two-tailed 10% alpha level. The critical t, so we want to look at degrees of freedom. So we know our n is equal to 31. So it's n minus k, right? And our k is equal to 2 minus 1. So it's n minus 3. Degrees of freedom are equal to 28. So we look at 10%, right? Two-sided. We go down. We're looking at 28 degrees of freedom, and we get a value, a critical t-value of 1.70. And so now it's asking you for the actual t-value. The actual t-value is going to be 0.3 divided by the standard error, which is 0.1. Okay. So technically it's 0.3 minus 0 from the null hypothesis divided by 0.1, and so we get a value of 3.0 for the actual t-value. So what is the correct decision? We know that our critical t-value is 1.7, our actual t-value is 3. Therefore, since 3 is greater than 1.7, we can reject the null hypothesis and conclude that the coefficient on the natural log of labor is statistically significant at the 10% level. So now it's asking you whether the coefficient on the natural log of capital is significantly different from 0, and this time we're looking at an alpha of 5%, a 5% significance level instead of a 10% significance level. So our critical t is going to change. So our critical t is going to be, degrees of freedom are still going to be 28, 31 minus 2 minus 1, or 31 minus 3 equal to 28. And so we look here now for a 5%, right, two-sided test, and we go down. And now our critical t-value is a 2.05. And our actual t-value is the coefficient on x2, which is 0.15, divided by the standard error, which is 0.25, and we get an actual t-value of 0.6, and this value is quite a bit less than 2.05, our critical t-value, so we cannot reject the null hypothesis in this case, and we conclude that the natural log of capital, the coefficient on the natural log of capital, is not statistically significant at the 5% level. Now for the next question, using our answer from 9, we test the hypothesis that beta 1 is equal to 0. So instead of doing a two-tailed test, we're now doing a one-tailed test. And again, we're using an alpha of 10%. So we're using an alpha of 10%, but instead of a two-tailed test, it's a one-tailed test. So the critical t-value is going to be, so 10% one-sided. We go down, we see degrees of freedom equal to 28. We see that we get a value of 1.31. Okay, so the critical t-value is 1.31. And do we reject the null hypothesis? Well, we know our actual t-value hasn't changed. It's still going to be 0.3 divided by 0.1, or our actual t-value is simply 3. And since 3 is greater than 1.31, we reject the null hypothesis of no positive relationship. Therefore, we can conclude that there is a positive relationship between the natural log of GDP and the natural log of labor. For question 14, we're testing the null hypothesis that r squared is equal to 0 against the alternative hypothesis that r squared is not equal to 0. Now immediately when we see this, we know that we're conducting an F test of joint significance rather than a T test of individual significance. So the degrees of freedom for the numerator, we know that the degrees of freedom for the numerator are equal to k, where k is equal to the number of partial slopes. So here we have 2, so k is equal to 2. And for the denominator, it's going to be n minus k minus 1. We already know that degrees of freedom for the denominator are going to be 31 minus 2 minus 1, or 28. Okay. So the actual f value, if we calculate the actual f value, so going back to our formula, we can see that our r squared value is equal to 0.82. So we plug in 0.82 divided by, and we know that our k is equal to 2, divided by 1 minus 0.82 divided by 31 minus 2 minus 1, or 28. So this is distributed as an f, right, with 2 degrees of freedom in the numerator and 28 degrees of freedom in the denominator. And our actual f value ends up being 63.7778. Okay. So the critical f value, and it tells you that we're looking at a 5% significance level. We need to look at our f tables. Degrees of freedom for the numerator are equal to 2. Degrees of freedom for the denominator are equal to 28. And so our critical f value is going to be 3.34. So 3.34 is the critical f value, and we know that the actual f value is quite a bit higher than the critical value, so we can easily reject the null hypothesis, and we can conclude, so yes, we can reject the null hypothesis, and we can conclude that the natural log of labor and the natural log of capital are jointly significant at the 5% level. Okay. Now, how would we interpret the y-intercept in this model? For the y-intercept, we need, in order to interpret the y-intercept, we need to get rid of the rest of the equation. So how do we get rid of the rest of the equation? Labor has to be equal to 1 unit, right? So that means that the natural log of labor will be equal to 0 if labor is equal to 1. And capital needs to be equal to 1 unit. So that would mean that the natural log of capital, or the natural log of 1, is equal to 0. So when labor is equal to 1 unit and capital is equal to 1 unit, the natural log of GDP is going to be 0.58. And so GDP, or predicted GDP, when labor and capital are each equal to 1, is going to be e to the 0.58 power, or 1.786 units.